Welcome. We're going to look at dividing polynomials here. And first, we're going to look when we're dividing by a monomial. This is actually the easiest of the three things to learn in this section, because all you do is you make separate fractions. So let's take A here, and we're just simply going to put the 2x underneath each of the top terms. So it's 12x cubed over 2x minus 20x squared over 2x plus 6x over 2x. And then what's going to happen is that 2 cancels in the 12 to make a 6. That x cancels out one of those, so that means there's an x squared on top. The 2 cancels into the 20 to make a 10. And the x cancels one of those to make simply an x. This 2 goes into the 6 3 times. And these two x's cancel each other out. Ooh, I didn't even mean for it to completely go away. I wanted to put a line through it. So we end up with 6x squared minus 10x plus 3. Simply by canceling things out. So in this case, you're using skills that you learned a long time ago and simply applying it to 3 separate fractions all at the same time. You first recognize that you have to apply that to each of them to make the separate fractions. On the second one, this is actually the same as A in terms of how it's set up. Even though it's using here the division symbol, that's still the same as a fraction bar underneath. So you're dividing each one of these by that 4x. But the 4x and the 4x. So now what happens is we look to see what things we can cancel out. 4 goes into 25 times, and that x cancels out one of those. So we get here a 5 and an x to the 4th power. So it's like taking one away from that one. Okay. And then plus this 4 goes in the 8 2 times, and this x cancels one of those. So we have a 2 and an x to the 3rd power. Now that 4 doesn't cancel out anything. This x, though, cancels out one of the 2 x's, so we have just an x. So we have minus x over 4. Now, and basically, there's nothing more that you can do. This here is exactly the answer. The only issue is that with the end of it, the x over 4 could be written. It's negative x over 4. I want that minus right in front of it. Could be written as negative 1/4 and then the x. Your choice which way. In a way, this one is probably better because it identifies the coefficient of the x, just like the 2 is identified and the 5 is identified there. So it doesn't matter which one that you do for that. I think I'd prefer that, but I'm not, I would accept either of them where there's a test question. Now let's take a look at polynomial long division. Okay. We're going to do a couple of these types of problems, and let's go over the way to do it. The first concept to understand is the same basic kind of division as if you had something like 83 divided by 5. We would do a 5 and the division symbol. And what we figure out is we have to get the 5 as close to the 8 as possible. Okay, so that means 5 goes into 8 one time. So I'll put a 5 down there, and I'm going to subtract it, and I get 3. And then I'm going to bring this down, and 5 goes into 33 6 times with a 3 left over. Now, remainder 3 is what you did in elementary school and a little bit of middle school, but we no longer use that anymore. What we would do is we would say it's 16 and 3 over 5. It's 16 and 3/5. That's actually plus 3/5, but we can put it together because we could do 5 times 16 to get up to 80, and then plus 3 and we'd be at the 83. Well, that's the basic kind of thing that we're going to do here. So let's use all this space that's over here, and I'm going to say it's 2x plus 3 because we're dividing by that. And here I'm going to put a nice big long amount of space to put 2x to the third power minus 7x squared minus x plus 21. A little extra, not going to hurt me to have that there. My goal is to get this 2x to be the same as this 2x cubed. So I have to think, what is it that I'm multiplying by to get that? What do I have to multiply to 2x to get it? One of the ways to think of it is I can do it as 2x cubed, divide by the 2x. 2's cancel, this x takes away one of those, so it's x squared that's left there. That would be what I have to put up here, and I could put it in any place. I could put it above the other x squared, or I could put it at the beginning. It doesn't really matter. I'm just going to put it over there. Why not? And what I'm now going to do with it is I'm going to multiply it to the 2x, and I'm going to multiply it to the 3. So this gives me 2x cubed, x squared times 2x. And when I multiply it to the 3, I get 3x squared. I want to put that in parentheses because I'm going to subtract it. If you're not used to using parentheses here, get used to it. Because if you don't put them and you put the minus in front of it, you're going to think of subtracting 2x cubed, but you're going to forget sometimes, just enough to lose points on my test, you're going to forget to do it subtracting the 3. You're going to add 3 when you should be subtracting it. Okay, so let's do that next step here. 2x cubed minus 2x cubed, this becomes 0. Negative 7 minus a positive 3, so it's negative 7 take away 3, makes it a negative 10x squared. So negative 7 of those minus 3 of those gives us a negative 10x squared. Now we'll bring this down, and we repeat the whole process. We need to make the 2x here into this negative 10x squared. So over here, I'm going to put negative 10x squared, and I'll put 2x underneath it. 2 goes into the negative 10, negative 5 times, and that x cancels out one of those. So we have a negative 5x. So that's what I'm going to put up here, minus 5x, and I multiply it times 2x. Ooh, and look, I get negative 10x squared. But then I multiply negative 5x to the 3, and that gives me negative 15x. Parentheses and subtract. Just like we subtracted over here when we did division with numbers, we're also subtracting here when we're doing it with polynomials. So negative 10x squared minus a negative makes that positive 10x squared, so these cancel out. And then now I hear negative x minus a negative 15x. So let's come over here and let me write that as negative x minus a negative, or plus 15x. So the minus here, negative here, cancel to make a plus. So it's actually 15x minus x, which means you should end up getting 14x. And we're going to bring the 21 down here. Okay. So I actually want to put these in blue for the new parts of it. Now back to this for a second here. This is the number one place where people make mistakes, is when they're subtracting and they end up not using it in the right way. So think very carefully every time you do it so that you can get that right. Make sure you're really careful about these. Now back to the 14x, we're going to repeat the same thing. We need to figure out, how do you make 2x into 14x? Well, I can do the long way here, doing 14x over 2x. The x's cancel, 2 goes in 14. 7 times, we multiply by a 7. Which means up here we have to add that 7. 7 times 2x gives me the 14x. 7 times 3 gives me a 21. And I'm going to subtract these. 14's cancel. 21, take away 21 also cancels. We get a remainder of 0. That means this is an exact factor. So the answer to this one, so that's a key concept, that if you get a 0 there, that is like the answer to it. That is, so here, or that is saying this is an exact factor. Over here, for instance, with 83 over 5, this was not an exact answer because it had a remainder. If it was exactly 16, if it was 80, 5 goes into 80 exactly. There's nothing left over. This one did have something left over, but over here it doesn't. So that means the x squared minus 5x plus 7 is indeed our result. Now, if I took 2x plus 3 and I multiplied it to x squared minus 5x plus 7, if I multiplied that out, this is the result that I would get. Just like if I took 5 times 16, I would get 80 plus 3/5, and I would get 83. Okay, so that's how you can multiply those two factors in to get it, to get the original. Now, let's do it again here. Okay. So if you have an idea what to do, do it yourself, stop the video, and then come back to it in a moment. And now you're back, and I will start doing this. So I will do x minus 4, the long division symbol, 3x cubed minus 2x squared minus 41x plus 4. So it looks like I need a little more space. So I need 3x cubed over x. Well, that's just that x makes one of those go away, so it's 3x squared. So I need a 3x squared up here, and then I'm going to multiply it to the x that gives me the 3x cubed. I'm going to multiply it to the 4. So that makes a negative 12x squared. And then I'm going to subtract. So those cancel, and it's negative 2 plus 12. Important to see, that's minus a negative. So it's plus 12, so I get 12 take away 2, so that's 10x squared. Many people doing this would make this negative 14x squared because they forgot that it was subtracting the negative, making it a plus. So be very careful. That's the number one place people make errors with this. If you avoid those errors, you can get this right. And now you know about those errors, so you can think very carefully about it. 41x. Now we repeat the same thing. So we have 10x squared divided by x. X goes into that square. Oh, in fact, now it goes away. I'll just go like that. It's 10x. I need a 10x up here. So it's positive because there's no negative I'm dealing with there. So 10x. 10x times x gives me the 10x squared. But I also have to do the 10x times the negative 4 to give me a negative 40x. Ooh, interesting how this is going to work out. So that becomes 0, and then negative 41 and minus a negative makes it a plus. So it means it's negative 41 plus 40x gives me a negative x, or a negative 1x. Ooh, nice. Something like that would be easy. Let's bring this down as a plus 4. Okay, with it. And now I need to take that negative x and I need to divide by the x to figure out what it is that I need to get. I need to make the x into a negative x, which is clearly going to be a negative 1. Cancel those out, and you always have a 1 on top, or it's a negative 1 times x if you want to think of it that way. And that means we need to put a minus 1 up here. Minus 1 times x, minus 1 times negative 4 makes a positive 4, and we are subtracting. So, oh, the x went away there. So these cancel out, and 4 take away 4 gives us a 0. That means that this is the answer, and it's an exact factor as well. I want to get that little line out. Okay. Now we need to look at what happens when we have a remainder. So let's take a look on the next page, and we have a couple of them with remainders. So let's walk through doing x plus 1, 15x cubed plus 7x squared minus x minus 3. So I need to do 15x cubed divided by x. Well, that's just making that square. So that means I need a 15x squared up here. 15x squared times the x gives me 15x cubed, but I also have to multiply it times the 1, which is relative. relatively easy to do, maybe very easy to do. So now 15x cubed minus 15x cubed, gone. 7 take away 15, we get a negative 8x squared. Bring this down as negative 8. In order to make x into negative 8x squared, we're going to need a negative 8x. So if I put x under there, it'll cancel out one of the x's, so it's negative 8x I need. Negative 8x times x gives me negative 8x squared. Negative 8x times 1, negative 8x. But we subtract these. Those go away. But here, negative x minus negative or plus 8x. So we have positive 8. 8 minus 1, that means we have a 7x now. And let's bring that down. To make x into 7x, we are going to multiply by 3. So up here we have to do I meant 7, not 3. We have to put the 7 here. 7 times x gives us 7x. 7 times 1 gives us 7. And then we subtract 0. But negative 3 take away 7 is a negative 10. So we have a remainder of 10. So what we need to do, because this is negative, it's a minus up here. Let's do that in black to keep it going. Oh, not squiggly. We minus, and we make a fraction with the 10 on top. So it's subtracting 10 over, just like the problem before with the numbers, here was a 5. We were dividing by 5, so we make the fraction over 5. We do the same thing here. Because it's x plus 1 that we're dividing by, we put x plus 1 under that. And that means that this is our solution. You have to put plus or minus, depending upon which it is, and then the number over the fraction of the remainder without the sign, because we're putting the negative in front, that remainder over the divisor. Okay, let's do it again. And at this point, again, do it yourself. Come back to the video when you're done. I'll start talking in a couple of seconds. Enough time for you to pause it and then start it up again when you have it done yourself. Or try to do it, and if you're stuck, you'll see me doing it and see what to do. All right, let's set this one up the same basic way. So I'm going to have x minus 5, the long division, okay, 2x cubed minus 6x squared plus x minus 3. And so my first thing to do is to think I have just an x here. Okay, so I'm going to do 2x cubed over x. That x cancels out one of those. So it's 2x squared that I need up here. Multiply it to the x, I get 2x cubed. And then I have to multiply it to the negative 5. So I get negative 10x squared here. And I have to subtract. So this goes away. Negative 6 plus 10 will give us a positive 4x squared. Because I have a negative and a negative, that makes it plus 10. Bring the x down. And then 4x squared, take away an x, that means it's 4x that I need to multiply by. 4x times x gives me the 4x squared. 4x times negative 5, ooh, negative 20x. And we subtract. So here now, this goes away, and plus x, positive x, minus a negative means plus 21. So it's 1x plus 21x, 20x's, we get 21x. Now, what do I do to x to make it into 21x? I'm going to have to multiply by 21. So up here I put plus 21, and then I do 21 times x, and 21 times the negative 5. Okay, so what I have is negative, and 5 times 21 is 105, and I'm going to subtract. So what happens here is 21 take away 21, all those x's go away, and this is because of these two negatives, We have positive 105, take away 3, so we have a 102 remainder. It's a positive number, so up here we'll put plus, and we'll put the 102 on top, and we take this divisor and we put it under the bottom, and that is our answer. Now let's take a look at doing synthetic division. So for synthetic division, there's a very specific setup to do for it. Okay? So the way this is, you set it up by doing a little box, a little space underneath it like this, and I'll show you why. We take the number that's on the bottom, but we take the opposite of it. Okay. Opposite. This is important. Memorize it. Take the opposite sign. You make it +4, and that's what you put over here. Now let's make that a little nicer looking 4. Okay. Then here we put the coefficients. The coefficients are the 3, the -2, the -41, and that's a 4. And the reason why we don't see it, notice we have 3, then 2, then that would be a 1 here. The reason we don't have an x there is because we actually do have an x. It's x to the 0, and anything to the 0 power equals 1, therefore we don't show it. But notice we're going 3, 2, 1, and then 0. So we use the coefficient of that one as well. And we write those coefficients over here. 3, -2, -41, and 4. And now, here's the steps of what you do. Immediately first, you bring the 3 down here. Then what we do is we're going to do 4 times 3. We're going to multiply those. I guess I should put the dot instead. We use x's so much. 4 times 3, and that gives us 12, and that's what we put up here. Unlike long division, where we subtract every time, we don't. We do the opposite here. We're now going to add -2 and then +12, which gives us a +10. Then we're going to do 4 times 10 and put that up here, and then we're going to add them. So it's going to be plus. So we go, basically that goes straight down, and here we add going that way, and here we add going that way. And I guess you could say in a way we're adding 0 here, so 3 plus 0 is the same thing. But that's not usually how we think about it. We'd say just bring it down and use the same one. Then we do 4 times the -1 to give -4, and we add those to make a 0. And a little thing that you might want to start doing is also put this in here to remind yourself that the last one either tells you it's an exact factor or it's a remainder. So in this case, we have the 0 as a remainder, and we aren't going to use it then. But now we have to make this into a polynomial. And over here, we add a degree of 3. This new polynomial, we call it a depressed polynomial. And my favorite and pretty much only good math joke is it's depressed because it lost one of its exponents. Oh, that's so sad, and probably a sad joke as well. So we do 3x to the second power because it has to be 1 less than the degree of the original. And then we start going down in numbers. So it's exponent of 2. This would be an exponent of 1. And then minus 1. And the x to the exponent of 0, which is 1, so we won't show it. So we use the 3, and we use the -10. Oops, I don't know why I put a 2 there. Oh, I know, I was looking up here instead. So it's -10. So So we use the 3, and we use the 10, that's a plus 10, and we use the 1 and the minus 1. So we're using these things for these numbers. And all we really have to add, we're adding the x's with their exponents. So what we get, and I want to bring back that arrow because that was what made the 12, 4 times 3 made the 12. So now let's write it out as simply 3x squared plus 10x minus 1, and that's our result, our answer. Okay, I'm going to get this sooner or later and get this to show that's what we got. Okay. Now, each of these up here could have been done the same way. If you notice, I believe it's this one right here. I did this one by long division, and then I did this one down here by synthetic division. You can decide which one's easier and do it that way, or simpler, or which one you remember better. Let's come on down here and do another one. Okay. And another one, I'll show you why this one seems to be faster in it. So I'm going to set it up like this, and I'm going to take this and use the opposite sign, and then I'm going to put the coefficients of 5, negative 9, and I'm going to tell you in a moment why I put 0, and then 14. Here's a 3. There's a 2. Oh, this one's x to the 0, but there's no x to the 1. If there's no x to the 1 like there should be in there, that's because the exponent of it was 0. So it was 0 times x to the first power, and that means it's equal to 0, so we didn't even show it in this polynomial. But for synthetic division, you must show it. Must include it from 0 times x to the first power. So if there was no x squared in there, that would be because it was 0 times x squared, and we put a 0 in this spot where the negative 9 is. I've now set it up. Let's follow through the steps. The 5 comes down here. Negative 1 times 5 is negative 5. Add these together. That makes a negative 14. Multiply those makes a 14. Add those together, and I still get a 14. Multiply these, and I get a negative 14. And add those together, and I get a 0, and that tells me this is an exact factor. I have a 3 as my degree, so I have to go 1 less to the degree of this. So my depressed polynomial is 5x to the second power minus 14x plus 14. All there is to it. So you have to set this up, and it almost seems a little bit like it's a game to do, but it's frankly a lot faster and easier than long division. I will tell you, though, that it doesn't work if you have or it does work, but it doesn't work easily if you have, I don't have one. Do I have one to begin? Yes, I do. Up here at the beginning, remember we had 2x plus 3. For synthetic division, we would have to divide that by 2 and have x plus 3 over 2. And every one of these coefficients would then also have to be divided by 2. All right, and then we would have to do the synthetic division with fractions and all of those. It's possible to do. If anyone is interested in learning to do it with that, come and see me, and we'll work it out. I'll show you how. But I would recommend that whenever you have a coefficient of 1 with the x, that you do the synthetic division. If you have the number in front of the x, a coefficient there for the divisor, then do the long division for that. Well, this next example is also synthetic division, or is going to be, because there's a 1 in front of the x, or no other coefficient. So I'm going to do this one. I would recommend you to stop the video, try to do it yourself, and then come back and watch. and see if you did it and got the correct answer after I've done it. Okay, go ahead and do that, and then come on back. Okay, now I'm going to start it. So you've come back already. We're going to use the opposite sign, -1, and then the coefficients, 15, 7, -1, and -3. There's no 0 needed this time because we went from 3 to 2 to 1 to 0. So each one of them. And I set it up with this. But remember, the setup requires that you do that half box and then that you do a line under, giving enough space that you can put numbers underneath the coefficients. So let's bring the 15 down. -1 times 15 is -15. Add those up to get a -8. -1 times -8 is a +8. Add that to get a 7. -1 times 7 is -7. Add that to get -10. This is not an exact factor, so we'll have to put the remainder in there as a fraction at the end. But we go from a degree of 3 to a degree of 2, -8x plus 7 minus, and we'll put the 10 over the original divisor. Notice it's the original one. It's not with a -1. It's the one with the +1. And so our final answer has to include that in it. If there is a remainder, you do it that way. Okay, let's do this. And then there's one more example down on the bottom here. Go ahead and try to do that one yourself too. Pause the video, do it, and come on back. 2, 1. All right. I'm going to do this. It's going to be a +5, opposite sign, and then 2, -6, x, oops, not x, I need the 1 that was with the x, and then -3. Bring the 2 down. 5 times 2 is 10. -6 plus 10 is 4. 5 times 4 is 20. That's 21. 5 times 21 is 105. Take away 3 and 102. It's not a 0, so it's not an exact complete factor, but it's still a multiplier. We can still multiply it out. So we do 2x squared, because we go from 3 to 2 for this one, plus 4x plus 21 plus 102 over the divisor, x minus 5. Let me yellow this one in. Notice that what I did here is that most of the problems here, the ones that I did here with synthetic division, some of them were the same ones that I did with long division. I just didn't do it with the one that had a 2 coefficient of the x for the dividing number of the divisor. So let's go back up and see some of those. So here's the one with 102. Here's the one with minus 10 as the remainder. So let's come on back down to that last one. And so you see, it can be a faster process if you follow all the steps and rules for it. Make sure you're very comfortable being able to do synthetic division. Make sure you understand and are comfortable doing long division so that you can do either one of them or both. And also don't forget about simply dividing underneath by, if you have a monomial, where it's just like 2x or 5x or 7x or 4x or something like that. And notice that's the difference. For polynomial long division or synthetic division, we are doing it with all these how would you say, with binomials underneath. So every one of them is a binomial. Okay, that's here. Thank you for watching. I hope this was helpful for you. So appreciate you viewing this.